All right. So yeah, welcome to lesson 16. This is the final lesson in this part of the course. I think we'd almost got to the end of the lesson 15 notes. We were talking about bonding curves, etc. And I just wanted to mention the security aspects. Um, these sort of tie in with the general security directions and ideas that you would have around DeFi anyway. Um, so we see possibility of front running. That's people can well, this is less on Solana as we said when we talked about MEV, but it is possible that people can uh, see transactions and then get ahead of them. Um, the one thing to be sure of is when you're interacting, uh, well, generally in DeFi, that you have something, you try and get some slippage protection, the which will mitigate the effect of someone get front running you and mitigate the effect of a large price movement. So, uh, yeah, that's what you can do. Uh, Other things that are possible, of course, price manipulation. If you have a large amount of tokens, large amount of capital, then you can attempt to manipulate the price. And that, yeah, of course, that's always possible. Um, it's difficult to know what to do about that because it gets very close to looking like normal trading anyway. But in the case of things that use a bonding curve, we do have some protection against that. So we uh, do the bonding curve itself does move the price in a certain direction. So yeah, the this will be more significant after the initial period. So yeah, if you wait, then it may be better. You may have less volatility at that point. Okay. All right. So let me move on to lesson 16. So we've got quite a few things to cover again today. So let's just dive into that. We did look at Gil a little bit when we were looking at building a UI and we looked at some of the different alternatives. I wanted to give you some more details of it. So we've got some more practical details here. Um, so insulation, excuse me, there's details there. Yeah, so I think that's very straightforward. Um, the first thing you need to do is to create a connection with some RPC client. The We have different types of uh, connections, or different components that are used for different circumstances. So you see that we have mostly we're going to be doing a HTTP connection to the RPC node for sort of the everyday getting state, etc. We may use a WebSocket connection that is more useful things for things like real-time events. Um, and then we have the right connection if we are going to be signing and sending a transaction, then we would use that. Okay. The When you set this up, then we can you can specify a particular URL for the RPC node, or there are known names, which I guess that's probably what you're going to use most of the time, such as DevNet, mainnet. Other perhaps if you're doing something at localhost, it would be different, but you probably would want to use those names anyway. As it says, it is very much advised that you uh, use a private RPC node when you're going into production, just so that you're not going to be affected by any kind of rate limiting. So what does that look like? How do we actually create the client? Well, we've got some example code here where we're going to connect to DevNet. And we've got some components that we're going to use there. Um, this one here, the second one is using a URL. If you've got your your private RPC provider. So that's the first part, is the actual connection. Then we are going to do something with that connection. We will likely need something that is going to be able to sign. So because we probably want to do some updates. So there are we have functions that will help us with that. So depending on how you are using your private key and where this is being signed, you may use different things. So you can have something to generate a private key and then use that. We may need to save a key pair also, so that's also possible. Or you may want to, and then you may want to load it from a file. So all of those are possible, but you do obviously have to be very careful that there's not the possibility of your key being leaked. So this is an example of that. This is loading it from a file, and then that will create a signer for you, and then you can use that to sign. The transaction, setting up and sending the transaction is described here. So one thing you may want to do is before you do a transaction, is to get the latest state so that you know you're not working with some stale data. And part of that could be the block hash. We've spoken about this when we spoke about the lifetime of transactions and the commitment levels. So hopefully you'll remember that. Um, so you can do that. You can use your RPC object to get that. But then you're going to actually want to set up the instructions and the transaction itself. So there are helper functions to help that. So yeah, you can have a look and see the different ones. We've got an example later on in the code that shows you an example of that. Once you've created your instructions, then you need to put them into a transaction. And so there's a function to help you with that. Um, the There are some extra parameters you can use as well. This first one here, this is what I mentioned the other day when I was talking about version transactions and the fact that we could put addresses into tables. So if you're going to do that, then you need to specify that. We need to say who's going to be paying the fees. Then we need the instructions and the latest block hash that we've just got. The transaction will need to be signed by the person who's going to pay for it, and accounts will need to be signed by the appropriate people for that. Yeah, and there's a function for that which is going to throw an error if needed signatures are missing. Once we've got that, then we're ready to go. So we can send out the transaction and wait for it to be confirmed. And there's a single function to do all of that. It is possible also to for this to have a transaction object that hasn't been signed, so that you can provide that. Then it will handle the signing process before it is sent. So that sort of combines the previous steps a little bit as well. So that's also possible. So here's all of that put together into one piece of code. So we're creating our client here, which is going to connect to DevNet. We are loading our key pair from file to create a signer. We're reading the latest block hash, so we're getting the latest state there. Then we're going to create an instruction. So this is a memo instruction, and then once we've got that, that's what we're going to do in our transaction. Then we can create a transaction from all of these pieces, as you can see there. when we have the transaction, then we can send and wait for the confirmation of the transaction there. Okay. So yeah, quite a neat little process, quite straightforward, I think, a way of doing that. So that's really the basics of what you would be doing. There are also some further advanced features that Gil will give you as well. And I think what they've tried to do is uh, to abstract away from some of the very common tasks that you might want to do and to build functions that are going to help you with that. So for example, the where you may have maybe a sequence of things that you would need to do. This can help uh, put that all together, and it creates this idea of transaction builders that are going to put all the parts together for you. So for example, if you're doing handling tokens or the metadata for NFTs, these can get bundled together into a transaction. They also do other help you with other things such as handling associated token accounts. We've mentioned those a number of times. Um, they can give you defaults because there are some things that are commonplace. They will know what the defaults are going to be. Um, and yeah, they can pull together many different interactions. So as an example of that, we've got the create token, the build create token transaction, and it can simplify the process of creating a token. So it can do that with the original token program, which could be a fungible or it could be non-fungible. For the non-fungible, also it will be able to handle metadata for you. And then it's been updated to also handle the extensions that we saw in the token 2022 program for that. Okay. So there's an example here of how you can do that. So um, we've got similar details at the beginning here, but then we want to put together all the details. So to take to create a token, a 2022 token. So we can use um, this the special builder, the transaction builder. So we're doing the build create token transaction and we need to pass all of these details in. So pretty much what you would expect. We need things like the the mint authority. We're also passing in metadata for the metadata standard. Um, Passing in the number of decimals and specifying that we want to use the token 2022 program. So we need to pass the address for that as well. So that will do all of the setup of the transaction for you. You then that gives you the transaction there. So you can do the send and confirm transaction, which will uh, give you uh, the signature, and well that will confirm it, and yeah, you can then find it on the block explorer there. Okay, so um, other things some very practical details that you'll need to think about when you are sending transactions are things like the priority fee that you may want to include because if the network is particularly busy or you particularly need your transaction to be included very quickly, then you would want to be including a priority fee as well. So that can be added quite simply. I think we had notes about doing this generally, but that certainly simplifies it. Um, Also, it has a debug mode as well. What it can do with this is it uh, you you can send a transaction and it will give you back details of that, which you can then look at in a special tool, the transaction inspector tool, and that will give you details about the transaction, hopefully help you work out where there was a problem, or you can use the simulate to go through and find out more details as well. So that could be very handy. Um, so what we've seen so far really is uh, interacting with sort of known programs like the token program, that kind of thing. But also, we're going to be writing our own programs. We want to be able to interact and work with the other major tool that we're using, which is Anchor. So yeah, we can do that. It allows you to interact with those. So you can use Anchor to build the program, and then you can use Gil for the client side for the user interface. Um, to help with that, uh, you know that we have this IDL file that can be generated by Anchor that is there as a description of our program so that the client knows how to interact with that. Um, so that can be used by this tool Kodama to take that description of our program and then to help build that into a client with typing so that it knows uh, the the types of arguments that are going to be needed, etc. So that having that will help reduce potential errors at runtime. Okay, so uh, yeah, I don't take too long on this. So, but there's an example here that should hopefully help going from. Let me get to the yeah. Um, sorry. This is showing you the anchor side here. I mean, it's a very simple program. It is just a counter that then can be incremented, but you can see we've got the details of the account, the data account, uh, and then we've got context as well to integrate with the functions we've got. So that's the anchor side. Once you build that, then that will give you the IDL, and then you you can use that to generate the client code, and you uh, sorry, it's difficult to scroll this. Then the client code would look something like this. So you your program is there. It's you want to call functions on that program. So, for example, the increment counter. So this would be client code that would help you with that. The first parts we've seen before, um, but then we need to work out the instructions and create the transaction. So we need to we need to get an address as well. We need to derive that. Uh, then we are going to get this instruction, uh, build that. When we've got that, then we can create the transaction. And then once we've got the transaction, we can send that off and confirm that. Okay. So yeah, there's lots to dig into there. I mean, this really has just been an overview, but I put in a few more examples to help you. I think it's certainly worthwhile having a look at, and it could uh, sort of speed up and your development of the client and uh, take away some of the sort of everyday things that you would need to write. So I hope that is going to be useful for you. Um, yeah, they wanted to an idea of different blockchains and what development on different blockchains is like. So I've put together some notes for this. I don't think maybe we need to go through all of it in detail. So you can read through it at your leisure. But what it's aiming to do is to look at the differences between Solana, EVM, and then move-based chains, and then a little bit about Cosmos. And this does represent some quite distinct ecosystems and quite distinct designs of blockchain. So um, I break this down into looking at some different aspects, and one of the first one of these is around the way that the execution works. And so starting kind of in the order of when these things happened, we have the EVM, which is single-threaded, it's a stack-based state machine, and it updates a global world state. All the nodes will verify the transactions and arrive at the same resulting state. So what this means when you're thinking about designing your applications or your programs is uh, that with the EVM, you don't need to know ahead of time what state is going to be accessed. Now, that's not completely true, because there are some optimizations that Ethereum is starting to introduce um, around the idea of sort of saying ahead of time what's going to be used. But really, that's more of an optimization. And in terms of development, you really don't think about that. You just think about what you're using at the time there. Um, this I think makes it simpler for development, but it does mean that this then becomes a bottleneck as well for the throughput. And specifically, we can't do any kind of parallel processing of transactions with the EVM. So in order to improve throughput, the approach generally has been to create other chains. So layer two rollups, for example, the ones mentioned there, the optimistic type of rollups. We also have the ZK rollups, but that's where the effort has been put into improving the throughput. With Solana, on the other hand, that was designed to have the ability to execute transactions in parallel from the start. Uh, in order to do that, though, to know uh, it does need to know ahead of time the what state is going to be used the uh, within the um, within the transaction, and it can then make an intelligent decision about. Oh, sorry about this. I'm getting phone calls. It can then make an intelligent decision about the uh, what can be run in what instructions can be done in parallel, and what then would need to be done in sequentially for safe concurrency. So you do need to be aware of that when you are creating your transactions. You've seen, we do need to know what accounts are going to be used in our transaction. We have to send that information in. And I've mentioned before that this means, for example, with a PDA, that the client may need to derive that, even if that hasn't been created yet and is going to be created in the program. Okay, so uh, yeah, but that really has helped Solana get much better throughput. The fact that it can do that, and then a even more recent approach has been with the Move language and the Move VM ideas with Aptos and Sui, and they they do a different type of uh, model. They do this idea of the of optimistic concurrency, and so they assume that they will be able to they'll be able to process things in parallel, and they won't get conflicts. Um, if But once things have been processed, then they check for conflicts afterwards, and then they can work out how to deal with those. Okay. Um, they Yeah, they have this idea of things being moved, and it is a little bit the idea behind move is similar to the idea of moving things in the Rust language, where within Rust we have the idea of ownership and uh, things sort of tracking the ownership of things. That is sort of extended out in the move language to apply to objects actually on the blockchain. The idea of things being owned and that you transfer ownership, and it is able to track that. Okay. Um, Then the other things that other things you would need to know when you're sort of comparing the ecosystems. The EVM, I guess, has been around longer. We're perhaps got more mature tools generally, but the main ones we that are used at the moment are Hard Hat and Foundry for development. Um, they do pretty much the same kind of things. I think I'd say Foundry is perhaps a little bit more advanced in some of the things it can do, particularly around testing. It's very fast. Um, yeah, but that's that. The On the Solana side, the tools we tend to use, so Anchor is really the main one as well. I've got some details here, but we've been through these many times. The fact that it takes away some of the mundane things for you. It abstracts away some of the things that you probably don't want to have to do. And as we were just talking about, it will generate RDL for you as well. So there's a few details about the tools there. And then other things to think about, more sort of general blockchain uh, things, are the idea of things being monolithic chains or modular. And certainly when blockchain started out, everything was monolithic. A chain would try to do all of the aspects that it was needed to do, and it would just so and the Ethereum mainnet would do everything. Solana mainnet would do everything it needed to. But then over time, people started to think that um, it it would be better to break that down. And so we get the idea of modularity in blockchains, and we have chains that have specific roles, such as doing data availability or execution, and then these will be linked to chains. Um, so that is moving over time. And Cosmos is a project that was designed to be able to link chains together, and it has a special uh, language to do that, this inter-blockchain communication. And so it is tries to be able to link chains together and allow them to communicate in a very general way. And we we have seen some examples of the example in SVM chain, but built on Cosmos. So these things are possible. You can build and configure chains and then attach them to Cosmos, and they will be able to communicate with the other chains on Cosmos as well. Okay. Oh, I don't know why this is not. Sorry, that should have come on a new page there. But that's the comparison anyway. So I hope that's useful and gives you an idea of uh, what it's like to develop on different types of chains and some of the differences. Okay. Now, something that we were asked about in the last cohort that I think you'll find interesting was someone was asking about sniper bots. This also comes in to or ties in with what we were talking about with launchpads and bonding curves as well. But certainly, you do need to be aware of this type of behavior. I mean, you can write your programs and be focused very much on the technical side of things, but as soon as your programs are going to be used, you do need to be aware of the types of behavior that happen on blockchains and potential problems that you may get. And the idea of the sniper bot is, which is not then they're not confined to Solana. This is a general type of automatic program. It's designed to do an execution um, very quickly and look for a specific event and then execute on that event. And the things that particularly sniper bots are about is the things they are looking for are things such as a new token becoming available, or maybe with on an exchange if a uh, perhaps a liquidity pool is created or liquidity is added, and then they try to take advantage of that. And the way that they can take advantage of that is that there's the assumption that they will be able to go in and get a low price because they're assuming that things are going to start at a low price and then the price will rise rapidly. And so they try to get in before the initial surge of demand, and assuming that there is going to be that surge. And if there is, then they they can then sell and make a profit very quickly. Okay. Um, yeah, so they're designed to um, buy very quickly as soon as something happens, and then um, they're waiting for prices to rise and maybe get to a sort of a plateau, and then they can sell, and then the effect of that is going to be that the price drops rapidly there. Um, and there's different strategies that they may have as well. Um, we we did talk about pump.fun as well, and the that that does assume, I mean, that is built upon the assumption, really, that a token will behave in this way, the price will behave in that way. But it does, if you remember, it does have some idea of protection as well. And we've just been speaking about the kind of protection we get with bonding curves and how they can exert a pressure on the price to prevent the advantage of getting in early as well. So you need to think about these um, in conjunction with what I was saying about the bonding curves as well. Um, this is just um, more details really about what a sniper bot would actually want to do. Um, it- yeah, and it's going to take into account details of the bonding curve as well. Uh, if it has that, then it can use that then to be more intelligent and make more intelligent decisions about the price. So it can factor in the bonding curve. Of course, what it doesn't know is what the demand is going to be, but it's typically going to be assuming that there will be an initial surge of demand. Um, but these sniper bots, they can be, they can be more sophisticated and look for different uh, types of orders. Something like a large buy order would be an indication that there's going to be increased demand. So that may be a trigger for to go in and try and get ahead of that. Um, oh, this is just details here of some uh, of the different chains and the the throughput and what difference this means. Um, I think the advantages that we get from Solana in terms of scalability, of throughput and low fees do mean that this things like running sniper bots is much easier. So it yeah, that's kind of a problem, I guess. Um, yeah, this it, opinions are going to vary, I suppose, about this, and um, these things are going in and buying tokens. Whether how you want to regard that, I don't know. I don't know whether you're going to regard that as the normal type of trading process, or as an unfair behavior in some way, something to try and remove. It, yeah. Um, there are strategies though to try to guard against the bots, and these are the kind of things that you would be wanting to think about if you are going to introduce a new token. Um, so you can do things like restricting the number of tokens that can be bought from a particular address, or also to have this cooldown period so you can't sell your tokens immediately as well. Also, if you know particular bots, then you could blacklist those. Um, the dynamic pricing idea, this kind of ties in with the bonding curve that will do that. But you could also, I guess, above and beyond that, put in something a bit like um, uh, quadratic voting, where the cost of something increases as you repeat it. So potentially in your code, you could add that kind of pricing in, maybe associated or in conjunction with the cooldown period as well. Okay. Um, I think this idea is quite interesting. The lottery uh, based approach, where things will be participants will be selected at random, so that could help reduce the effect of sniper bots. Um, but it really just then says, well, are people just going to create more of them and create more addresses? You get the kind of Sybil resistance problem then. Um, but yeah, I don't know if I would. Yeah, I think we'll move on from there because we're going to run out of time otherwise, I think. So let me move on. Um, so validator nodes. We spoke a little bit about these as well the other day. Gave you some idea of the hardware requirements for running a node. Um, this is really going through the process in more detail. So it's useful to know as well from the perspective of when you're introducing a transaction and how all of that works. So we start off with the validator node receiving the transaction. Um, we the transaction will include a number of accounts which will have been signed. So we want to verify those signatures, and to do that, one possibility is to uh, be able to do that in parallel by using special hardware for that. So that can help um, with that. Uh, there's there will be some verification done of the transaction when it is received, and it wouldn't get passed on otherwise. Um, we have this concept of also looking for stale transactions or duplicates as well, so they can get rejected. Um, then uh, we can process it. Um, uh, the validator also needs to be able to vote on the blocks that it receives. So we've got that side of things as well, with the stake that they have, and the fact that the blocks will get agreed based on a BFT based consensus. Um, and we spoke yesterday, I think it was, about the fact that the we have this idea of shreds where these can be streamed out to are the validators to make the whole process more efficient. Here's some details about the rewards involved. Yep. And if you are interested in running a node, there are also some things that you will need to monitor as well. So uh, yeah, if you're going to keep your stake, you need to make sure that your node is running correctly. And for example, if you are given a leader slot, then you need to make sure that you're taking advantage of that and not skipping that, etc. Um, yeah. Now, that was just some general details. There are some specific clients that have been created recently. Um, so this is Agave and Fire Dancer. Um, it it is a good idea generally to have multiple clients available on clients here. I mean the validator software. It's an advantage to have multiple different clients from the resilience point of view, just in case there's a bug in one client or there's some problem with the design of one client, then you're not completely reliant on that. There's some further details about that, but I think we need to go through that in much detail. There's yeah, a little comparison there. Okay. Okay. Another uh, extra topic is around the idea of auto rebalancing. And this is looking at the at liquidity pools in a decentralized exchange. And the idea of auto rebalancing is that it's a mechanism that's going to adjust the ratios of the assets within a pool to try to make this optimal for the um, is to try to give them the best returns. Okay, and so these are things. This is going to be done automatically to try to keep the pool in a certain state to keep a target ratio of the assets. It yeah the point is to make the most to optimize the way that the liquidity within the pool is being used. We saw well, I don't know if I said much about it, but the the way that decentralized exchanges work, the original ones with liquidity pools would provide liquidity at any price. There was just liquidity available generally. Uh, More recently, they started to do that so that you can, when you add liquidity, you can specify a price range where that liquidity will be available. And this again is all about making that more efficient. Uh, um, yeah, this is details of how this is actually achieved, the mechanisms involved there. So, for example, here they've got a bot that checks every 20 minutes and then will try to rebalance according to different strategies for that. Um, yeah, I think I need to go through all this. You can just, yeah, this sort of summarizes everything there. I think I need to sort of move on really, but yeah, if you're interested in rebalancing, there's some details about that there. Okay. Now, one thing that Solana became perhaps a little bit infamous for over time was uh, network congestion and the way it has reacted to that. And in fact, if you've been uh, doing transactions on Solana, you may have noticed that you can get quite a high failure rate. Um, I don't know if I've got, no, I don't have, this ties into times also where the network halted, which obviously for a blockchain is a very drastic situation to be in, a dangerous situation to be in. And I think that one of the problems is that Solana is really a victim of its own success. And because it is trying to achieve very high throughput and low fees, it means that people try to take advantage of that, and they will really try to fill up the network as much as possible with transactions. And I think we talked about the idea around things like arbitrage, where you people may pump in just lots of arbitrage transactions, even knowing that the majority of them are going to fail. But from the from the person introducing those transactions, it's not such a problem if those transactions are cheap. So they're able to do that, and they will see it as a win if just some of the transactions work. And so they can sort of happily ignore the failed transactions. But from the network point of view, there is going to be an impact. The fact that these transactions still have to be processed is going to be an impact. And what this means is it is putting pressure on the software that is used for the validators. It's putting pressure on that to be, as efficient as possible, and then also the hardware as well. And when we mentioned the hardware, you saw that the requirements for memory were very high, and we've seen that um, when there were some events where the network had problems. Uh, this was often because there was so much demand, so much throughput that it exceeded the memory capacity of many of the validator nodes, and then they couldn't proceed. So yeah. Um, what what can we do about this as developers? Well, obviously we can try to make our code as efficient as possible. Also, we can make sure we can, we could use things like priority fees if we want to get our transaction ahead of other people's. We can add extra fees to that. There's an example of how you can do that as well. In terms of how to judge what values to use for that, there's a method you can call which will give you some metrics from recent blocks, for the last 150 blocks there. Um, then in terms of your program and the amount of compute units it's using, um, there's a cap on this, and so you obviously need to make sure that your program is going to be below that. Um, but just generally, it makes sense to try and reduce that as much as possible, because if your uh, program has very low requirements in terms of the compute units, then that means that the transaction is going to be smaller, and smaller transactions will fit more easily into blocks, or they're more likely to be able to fit into a block alongside other transactions. So it makes a lot of sense to try to optimize your programs. And yeah, uh, if your program is going to be composable, again, the same thing. You want your parts to be as cheap as possible so that you can compose more things from it. Okay. Here's an idea of the limits. I think we've said this before, and how you can work out the amount of compute units that you've used as well. Okay. What I didn't say here, although I have mentioned it before, again, also is the fact that there are restrictions on the amount of memory that your program can use, and the stack as well. So you do have to be quite efficient in the code that you write, and don't be wasteful. Okay, let's move on to Deepin. So this uh, was a bit of a buzzword for a while. but I think it's still, I mean, I think there are lots of projects building in this space. What it is all about is, um, yeah, is physical infrastructure, but making that decentralized. So here are some different aspects, some of which we're very familiar with. So, for example, with storage, we've got things like Filecoin, so decentralized file storage system. So they've been around for a long time. Um, CDNs we've known, obviously they predate decentralization generally, but this is trying to decentralize those as well, or VPNs also. Um, Also compute, allowing providing compute services as well of different types. Um, Something obviously is going to be more increasingly popular is going to be on the AI side. But then more general physical things such as sensors as well are interesting. Mobility. So there are lots of different, potentially different areas. And so I've got some links here to articles about that. Um, the quote here from Vitalik. Uh, yeah, so there are a lot of these things have been around for a while. It's just seems to be they've got a name now. What they rely upon, well, they're going to be decentralized. They need the architecture to run in. They'll need programs to allow them to make decisions and charge fees, etc. They need a network, but then we've got the blockchain network there. The blockchain can give the rewards, can incentivize by using tokens. Um, Also, some things may happen off. There may be a mixture. Some things may happen off chain, and then there may be an on chain aspect to say do rewards, etc. Okay. So what uh, what do we have on Solana? So here are some examples. I've got links there to some articles if you want to read more about them. Yeah, this is a little bit old, but it gives you an idea of some of the things. Um, the first one, helium, the idea there was that it would create hotspots so that people could connect to use that as a Wi-Fi connection, and then you get rewarded. I actually had one of these running at one point, um, although that was before it moved on to Solana. Um, but yeah, that's to try to provide a wireless infrastructure. Um, Other things, rendering by providing GPU resources. There's that. Um, this one is a uh, yeah, to provide network services and storage, RPC nodes, etc. Um, this one is interesting. It's a uh, to do it's providing storage, but it's doing it in a way that is based on a more of a mobile architecture. Um, yeah. So they've taken a kind of slightly different approach, and there's lots of links there if you want to try these things out and include those. There's you got SDK there that are available. So moving on. So other general resources for you, but these are some more general ones. The general documentation. The Solana cookbook is quite useful because it has more practical examples that you may be able to adapt to your for your own means. There's a blog as well about what's happening in Solana, and they have a podcast there also. I've spoken a little bit about the Solana community um, already, but just wanted to re-emphasize that I think they do have quite a strong and active community. They certainly have lots of resources available. The the flagship event for that is Breakpoint, and that's happening in December this year. This year's one, this this countdown isn't correct now, but yeah, that's when it is going to be happening. All these events tend to be amazing if you can get to them. Also, there are events going on all the time. These are some just some examples. So sorry, some of these are past, but yeah, some of these are coming up as well. So there's lots of events going on in many different cities, lots of different meetups there, and hopefully this link is correct still. Yeah, there you go. So that's the events page. So do check that out. And then they they've brought this to help build the community. They've got the idea of the super team as well. And so super teams have been set up in different locations to try to bring together developers and to allow them to give each other support and to share resources and act really as a focal point for building within that area. And so yeah, some links there and some photos of um, various teams as well. The if you're that I think is more focused on building applications on Solana. If you're more interested in working on the ecosystem and working on the core projects, then there's the Solana Collective, and there's a link there to docs about that. And then the grants. The grants are available, and this was just a list that they gave out of areas that they were looking for in particular, but that's certainly not exclusive. And I do encourage people to apply for grants generally. It's you may well get something to help build a project. If you've got an idea and you want to build it out, they will often help you do that. And even if they uh, aren't able to give you a grant, they will often give you advice. So, for example, it may be that you're trying to build something that has already been built or is very similar to something else. And so they would probably be able to advise you about that, or maybe put you in touch with people, the other team that has been building whatever. Um, so you're almost certainly going to get something out of applying for a grant. So it's well worth doing that. Okay. I don't know, something that people always often ask about with grants are things around KYC. I think is probably going to be the case that you would need to go through KYC if you're going to get a grant. I don't think I've got one from Solana, so I haven't gone through, I don't think, through that process there as a grant. But yeah, typically speaking, they do want uh, most most projects, most blockchains will need you to go through KYC process if they're going to give you a grant. Um, then on the super team side as well, they have these things where you can they will provide small projects that you can work on, various opportunities that you can pick up. So, for example, they've got things where they'll give you 300 USDC to if you write an article, etc. So these are things that um, you will be able to find from your local super team as well. So it will be a mix. There will be some things that are about marketing and building a community. There will be some things that are more technical. So that could be writing a technical article, or there could be things that would want you to write some code. There will be a mixture of those. So that's something worth looking at. These things tend to be relatively small. They're not massive projects, but yeah, they're smaller things that you should hopefully be able to pick up. And you can, if you look at your super team, you can filter these things out according to various criteria. You can also get alerts for them as well. So worth checking out. Okay, so let me, in the remaining time then that we have, just go through a quick review of the course. So we started out looking at decentralized systems in general, what are blockchains, how do they work, and some of the technology behind them, the cryptography behind them. Again, I would ask you to do remember that if you're building on Solana, you're building decentralized systems. There's a reason that you chose to do that, to chose Web3 rather than Web2. So don't forget that the sort of the philosophy behind it. Excuse me. We also discussed the Solana architecture in general and how consensus can be achieved in decentralized systems. That took us into digging into the components a little bit more that make up Solana and its history a little bit. We also mentioned the community then, and then started to look at Rust, and Rust really dominated the next few lessons up until about lesson 6, I think. Um, but yeah, that was we were trying to teach you Rust, assuming that you hadn't really used it before. So we had lots of details about the language, but also we introduced started to introduce your interaction with the blockchain. So things like getting the command line set up so they could interact with the network. Lesson 4, more about Rust and errors, for example. And then a little bit, we started to look at details of developing on Solana and things like traits that were being used. Lesson 5 is where we really uh, looked at, what makes Solana different from a development perspective, where we started to look at the programming model in much more detail and really thought about the fact that our programs are immutable. Therefore, the state that they're going to interact with needs to be passed in, and that state is involved, that is held in accounts. So they will get passed in with the transaction. We started to look at that process and some of the tools that can be used as well. Um, Lesson 6, we really finished off our look at Rust. Of course, we didn't cover everything to do with Rust, but I think we covered enough that you can write some reasonable programs on Solana. And so that final part there was talking about lifetimes in Rust as well, and the borrow checker, and any how you may need to add extra information into your code so that that will work. Um, then we started to look at DeFi, just generally initially, and then more particularly on Solana. And we looked at tokens on Solana. And similarly to the fact that the programming model is quite different to other blockchains, with tokens, the way that they are implemented on Solana is quite different to what you may have seen before. But it is once you get the general idea behind it, then that's really all you need to know. Whenever you see tokens, you'll know that they are using the same type of architecture, the same components. You have a token program, you have a mint account, you have a token account. You may have metadata as well. So we went through all of that. We dug into programs a little more and started to look at these special types of addresses, the PDAs, and looking at why we need them and how we can derive a PDA, how we could find one. We then looked at, in lesson 8, we started to look at uh, security in a little bit more detail or a little bit more sophistication. Whereas previously we'd been looking at how accounts would be owned by a particular program. Then we started to think about, well, that's okay, but then how do we make sure that a particular transaction or an instruction is allowed to be done by a particular user? So we started to dig into that area a little. We looked at the upgrading programs as well, which is fairly straightforward. The only things to think about there, I think, are, well, a couple of things. One is to do with the size of the program. You do need to have to do that intelligently and have an idea of that when you start, how big your program is likely to get. Um, but also some of the philosophy behind upgrading as well. The fact that maybe your users would uh, may not be comfortable with the idea that a program would be upgradable, and so you have to be very explicit about all of that. Um, we looked further about program flow, so the when you receive an instruction, how is that actually then processed within a program? And we looked at how different modules are set up and the different concerns that they have. And we went through an example of the token program and looked at how a mint instruction could goes through the code and how it progresses. We also then looked at PDAs in more detail uh, because of the when we are deriving a PDA, we that is based upon information. Part of that is the program, but then we also have these things called seeds that will also determine the address. And we looked at the design that you may want to, or some designs you may want to think about when you're deriving a PDA and how those designs uh, correspond to the type of application that you've got. In lesson 9, we just briefly mentioned the interface definition language because we're going to be using that. We also looked a little bit more then at cross-program invocation. This is where we need to use our PDA, so we looked at how that is done, and then we started to look in more detail then about Anchor. So up to this point, we'd been really focusing on the native Rust programs and what you need to do for that. But then at this point, then we moved over and said, well, there are things that are mundane, that are everyday, that we don't want to have to spend our time doing when we want to spend our time thinking about the business logic, and Anchor can help us with that. But it has its own way of working, and so we talked about the functions, the account definitions, and then the context that sort of link the two together. And we went through some examples of how you can design a program, um, and yeah, how that can be written using Anchor. The next couple of lessons were all about interacting with our programs. So we started to look at some of the libraries that can be used and the types of functions that you would use with libraries. And then also we looked at some example code, some boilerplate code to give you an idea of the things you do when you want to interact with a wallet, for example. Um, in lesson 11, we took that further and looked at more examples and some other frameworks that you may want to use that will really make the UI more efficient. And yeah, then lesson 12, we looked at the some of the programs that are supplied for you by Solana in the Solana program library. And we'd already looked at the token program, but then we looked at some of the other ideas or the other programs that are available as well, such as those used for governance. Um, we then looked at Anchor in a little bit more detail. We looked at Solana Pay. which we came back to when we looked at blinks and actions as well. And then we looked at inscriptions, and then we started to look more at NFTs and introduce those. And really looking more at the way that NFTs are used now. So even though we'd looked at how to do a very basic NFT really early on, we then start to look at the way that NFTs are actually used and the metadata that we need for them and the tools that are useful when you're creating an NFT, creating a collection, etc. And that continued in lesson 13 with some of the tools that are available. So we'd looked at the Metaplex sort of umbrella project and some of the parts of that, such as County Machine and Gumdrop, etc., that will help you with uh, creating NFTs and selling them, setting up collections, etc. Then, as well as Metaplex, we looked at an alternative, which is LibraPlex, and went through some of the differences there. We discussed XNFTs, which are executable NFTs, and they're meant to be a simple way to interact with programs, and they can be stored in a wallet. We also looked again at security. We'd done some aspects of security before, but we just went through further details of security as well. Things like being careful about accounts and not getting account confusion or when you're they're being processed. And we saw that Anchor actually helps us with this. That's one of the big benefits of it. We also mentioned meme coins at that point as well, which were a large part of the use case, I think, on Solana for a while at least. Then we mentioned Token 2022, so the extensions that we have to the normal token program and what the kind of things that gives us, such as confidential tokens, but other smaller things as well. We looked at an area that is perhaps less significant on Solana than other chains, which is things like layer 2 solutions and interoperability. And this is because the way that Solana scales has been to scale the layer 1, whereas on other blockchains they've looked to moving to L2s, but Solana is still very much focusing on changing the L1. We went through some more designs around with Anchor, and we had some examples of well, we'd already seen PDAs, so we went through that, and also CPI, which I don't think we'd looked at on Anchor before. We mentioned versioned transactions as well. Looked at Solidity and other languages, so Seahorse, and we made the point that this is the language that you can decide to use a different language, other than say Rust, but you still have to be aware of the programming model. You still, it still ends up creating a program, and you still need to use accounts. So it's not that's with Solan that does give you the language, but that's not EVM compatibility there. Okay. And we spoke about some of I think that was the hardware requirements for running a validator that we spoke of there. Um, Yesterday, we covered many different topics, such as identity solutions. We talked a little bit about privacy. We mentioned MEV, but only in not much detail. Similarly with game development. Commitment levels, we spoke about just they're useful. That's useful to know that terminology. We showed examples of interacting with wallets. We spoke about airdrops and the different designs for those, the different approaches you can take with that. We spoke about SocialFi as well, and blinks and actions, which we kind of got a good example of that with Solana Pay originally, and did some optimization tips, and we did other things as well. And then today we looked at further examples of GIL and how that can be used. We compared different blockchains and development, how development compares on different ones. Oracles we'd done in a previous lesson. All right, that's great. And yeah, lots of luck in your future endeavors. Thanks. Bye bye.